All right.
This is doing good.
Okay, so we are on your last day of polars. Okay. Okay, you'll notice that our last couple units are all pretty short. Okay, so we did 3 days on vectors, review test. Okay, polars is only 2 days. So after this, we're done with notes on polar. Then you'll review tests next week. And remember, you have a 4-day weekend, so you won't have any like notes next week. Okay.
Yes.
All right, so let's just review what we did last class, especially since I wasn't here. I have the wrong. Sorry. I'm
Oh
sorry.
God, we're about to get rounded out. Jump back there with some motion. Oh my God, bro, you gotta kill me. Please have a program.
Oh, okay, bye.
Bye.
All right, so a Cartesian coordinate is an x comma y. And then a polar coordinate is an r comma theta. But remember that these are just different ways to graph points. So if I was graphing 4, -2, I'd go 4, -2. -3, 0, -3, 0. Okay, so you should be able to graph an XY, and now we've added r theta. There are 2 ways for you to do it. You can do it in degrees or you can do it in radians. So my first circle is set up in degrees. I want 3, 150. So I'd go to 150 and then count out to the 3rd ring. For a -1 radius, do you remember what you do from those notes? Count backwards, very good. So if 210 is here, then rather than me counting towards the 210, I would actually go the opposite direction and end up on the 30-degree line. Okay, and then remember, the number of rings that you count out is what your R is, or your radius. Okay, same thing. This time we're in radians, but it's the same idea. I want 4, 3 pi fourths. Then I'm going to find 3 pi fourths, and I'm going to count out to the 4th ring. So 1, 2, 3, 4. For -2, 3 pi fourths. Oh crap! I put it on the wrong one. Dang it. Should be right there. Okay, not this point. That point. Okay, then for -2, 3 pi fourths, instead of counting towards the 3 pi fourths, if it's a negative R, remember you just count the other way. So I would end up going this way towards 7 pi fourths. And I would end up on the 2nd ring, so 1, 2. Okay. So as we were doing that homework last time, okay, if you need resets or something, just tell me and I'm happy to do it today, but you should have time to go back and finish that if you need to. So the other thing that you learned last time is how to convert from the r theta to the xy. So now we're going to go the other way. That if you have the xy, you'll be able to turn it into an r theta. Okay, the way that you're going to do this is literally vectors all over again. Okay, your theta is going to be tan y over x. And then to find your r, you're basically still doing a squared plus b squared and taking the square root. So if you think about it, this is just like your direction from the vectors unit, and this is just like your magnitude from the vectors unit. So really these units are like so close that if you could do it with vectors, you should be able to do it with polars. So let me show you what I mean. Convert the point 2, 6 into a polar point in degrees. Well, then I would say, okay, if 2, 6 is my x, y, then in order for me to find my theta, I'm going to do tan theta equals 6 over 2. Because remember, it has to be y over x. And then do you remember how to solve it in the calculator? Second tan, very good. So go ahead and do that. Okay, you have to be in degree mode for your answer to come out right. Here you go. So we're doing second tan. And then 6 over 2. And I got 72 degrees. Technically 71.5, but we'll round it. Okay. Ooh, and then also let me say, you do still have to consider, do you remember that little chart? But if I'm doing 2, 6, what quadrant would that end up in? 1. So if I go 2 and then 1, 2, 3, 4, 5, 6. Okay, I'm in quadrant 1. And do you remember I erased the formulas, but what do you do in quadrant 1 to your theta? Keep it the same. Okay, so that will stay your answer. Okay, second thing we need is our radius. So remember, you're gonna do 2 squared plus 6 squared equals r squared. And then to solve it, you're gonna end up taking the square root. Okay, which is exactly like magnitude for vectors. So we'll do 2 squared plus 6 squared. That gives me 40. And then the square root of 40 is 6.3. Now, for your homework, if I remember correctly, it says you need to leave this as an exact value in radical form. So that means that you would use this one. Okay, the reason I had you do it as a decimal is I want you to think about how this would place you in the same spot. That you would go to 72 degrees. Let's just kind of sketch it here. So if this is 90, then we would say 72 is maybe this way. And then you would count out to the 6.3 ring and it would put you in the same spot. So you'd go 1, 2, 3, 4, 5, 6.3. And do you see how you'd end up in identical position, whether you graphed it as an XY or you graphed it as a polar? Okay, so this would be 72. Is it? Never mind. It should be the r first. So it should be square root 40, comma 72. Okay, but whether you graph it as 2, 6 or root 40, 72, you should map to the same place in quadrant 1. Okay, go ahead and turn the page. All right, let's do the second one. So remember, I want to turn my x comma y into an r comma theta. Okay, I want to turn, this is an xy, and I want to turn it into an r comma theta. So the first thing that I'm going to find is my tan. So tan theta equals y over x. Okay, remember, you're going to ignore any negatives. So second tan on my calculator, 4 over 3. That gives me 53 degrees. Now remember, if I'm in quadrant 1, that's my final answer. But if I'm a -3, 4, let's see what quadrant that puts us in. So you do have a little grid down here at the bottom. -3, 4 would put me here. What was the formula for that quadrant? Do you remember? Subtract from 180, very good. So if it's 53, I'm going to put here quadrant 2. Means 180 minus 53. 180 minus 53 gives me 127 degrees. So I'll put blank, comma, 127. Okay, remember the theta is the second digit. Now we need to go back and find our r. How do I find r? Same as vectors. A squared plus b squared, then take the square root. So it'd be 3 squared plus 4 squared, and then take the square root. 3 squared plus 4 squared is 25. Square root of 25 is 5 exactly. Okay, then from there, I want you to come down here to your polar grid, and I want you to graph this point. Now, 127 isn't going to put you perfectly on one of the angles, okay, but we can estimate where it would be. That if this is 120, 127 might be just a little bit past there. And then how many rings out do I count? What was my R? 5. So then I'd go out 1, 2, 3, 4, 5. And you can see that whether you mapped it as an R theta or an XY, you end up in identical position. Okay? Yes. Because it came out exact. So the question was, why did we take this square root, but last time we left it as a square root? If it's a perfect square root, go ahead and do it. But if it's like the square root of 26 or 27, that it comes out as a decimal, that's where you would leave it in radical form. Okay? All right, we're just gonna do one more because I feel like hopefully y'all are kind of getting the idea. Let's do number 4. Okay, 7, -4. Go ahead and grid it on your Cartesian coordinate. So 7, -4 is an x comma y. So I'll go 7, -4 is right here. This is point C. Okay, then from there, I'm going to find the theta and the r, and then I'll regraph my point here. So it's going to be tan theta equals y over x is 4/7. And then we're going to do second tan 4/7 to get theta equals 29.7. We're going to round that to 30. Now remember, if I'm mapped in quadrant 1, that stays the same. Okay, but if I have a negative in one of these, you know it's not going to be a quadrant 1 angle. So 7, -4 ended up down here. Does anyone remember the formula down here? 360 minus, very good. So I'm going to write here, this is a quadrant 4 angle, which means I'm doing 360 minus the 30 to get 330 degrees. Okay, but remember, it's r comma theta comes second. So next, let's find our r. Remember, that's going to be a squared plus b squared. Don't consider negatives. So it'd be 7 squared plus 4 squared. Take the square root. So that gives me the square root of 65. And then the square root of 65 is about 8.1. Okay, but remember, for your homework, if I remember correctly, you're leaving it as a perfect, as a square root. You're not rounding it. Okay, but now let's see about where this would end up. So I'm going to find 330 degrees. Then I'm going to count out to the 8.1 ring. So if I'm down here, 330 degrees would be here. And then I would count out 1, 2, 3, 4, 5, 6, 7, 8 would put me about right here. And even though we don't quite have an 8th ring, you can kind of see that you're in that exact same position regardless of how you graphed it. Okay, do you have any questions on that? All right. The last part of this is very easy because your calculator is going to do all the work for you. So I want you to take your calculator and I want you to change it into polar mode. Okay? Polar mode. So look at my calculator. You're going to have to change 2 things. First one is you need to go back into radian mode. And then the second thing is you're going to switch yourself over to polar mode. Okay, so polar is here. So you want to be all of these down the left-hand side, but instead of function, you want to be in polar. Okay? Everybody switch that? All right, so then go into your y equals. Okay, so these graphs are a little bit weird, but like I said, your calculator is going to do most of the work for you. So if you want r to be 3, hit y equals, and you'll see that instead of a y equals, now you have an r equals. And then what am I going to type in? 3. Now, when you hit graph, and actually hit zoom 6, just in case someone messed up your window. So zoom 6 will bring you to that standard 10 by 10 window. Okay, you'll see that you have a circle that showed up on your graph. That's because if you want ring 3, you would just stay 1, 2, 3 right on this ring. Now you'll notice on your calculator, it looks kind of more ovally. The reason why is because your screen here is not a square. So just kind of squish the picture, but this really should be a perfect circle. All right, let's go to the next one. Come down here to 4 sine theta. Type it in for me. 4 sine theta. And then for the theta, you're just going to use the X button. Okay, then hit graph. Okay, and you'll see that now you still have a circle, but instead of it being perfectly centered, it's going to hit at 0 and it's going to hit at 4. So just do your best to sketch that. You want to hit at 0 and then 1, 2, 3, 4, and then just kind of draw your circle in. All right, next one, we want 4 sine 2 theta. Go ahead and type it in. Remember, theta and x are the same. Okay, go ahead and hit graph. Wow, you have a flower. Okay, now when you draw your flower, okay, the length of this petal, okay, they're called petals usually, is gonna be what this number is in the front. So you'll notice that on this one, your petal, even though it's literally just a flower with one sad little petal, is 4 long. That should be the same case for this graph here. So I want you to count out to the 4th ring. 1, 2, 3, 4. And then 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 just kind of do your best. Okay, they don't have to look perfect. Okay, but it should look like that. All right, type in the next one. How long are we expecting the petals to be for the next question? 6 should be how long the petals are. So when you graph it, you should see petals that are 6 in length. So 6 sine 3x. Okay, you'll notice that this one has 3 petals. So you're going to count down 6 for the first one. 1, 2, 3, 4, 5, 6. And then you'll count out 6 this way. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. Okay, but when you graph these on your delta map, it's pretty easy because you could just like pick the number of petals that you want and kind of stretch the graph. Okay. All right, next one, type in number 8. Okay, rather than a sine, we're going to do a cosine this time. So 3 cosine theta. Three cosine theta. Okay, how many petals do we have? 1. How long is it? 3, which is the number in the front. What changed though? 1, 2, 3. With the orientation of my petal. Rather than it being an up and down petal like the sine one, do you see how for cosine, it's the petals stretched along the x-axis? Okay, go ahead and type in the next one. So now we want 6 cosine 2x. We're expecting petals to be a length of 6. Okay, and we'll notice that we still have a flower. Okay, but instead of me going down the diagonals like I did for the sine graph, now my petals are perfectly centered along where those axis lines are. Okay, so make sure you count out to 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, but it still had 4 petals. They're just aligned differently, that instead of being down the diagonals, okay, they're right along the x-axis. Okay, next one, I want 5 cosine 5 theta. Okay, you'll notice you have 5 petals this time. Okay, and they're all a length of 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. And y'all, I'm just kind of guessing which line I'm on. It's not a huge deal. When you do it on your homework, if you line up this one, all the other petals will like fix themselves. Okay. Okay, so let's look at some patterns now that you've graphed. We see that these are going to be petals. Okay, we've already talked about that the leading coefficient, that's the number in the front, determines the length of the petal. Now let's talk about how many petals your graph is going to have. If your number on the theta is an odd, you're going to have that exact number of petals. Here's what I mean. What was the number on theta here? Okay, look up here. What's the number in front of the theta on this one? How many petals did I have? 5. On this one, what's the number on theta? How many petals did I have? 1. Let's look at the other odd one up here. I had a 3. How many petals did I have? 3. Now let's talk about if it's even. When this was a 2, I had double the number of petals. Okay, when this was a 2, I had double the number of petals. So the pattern is that the number of petals is going to be the same for an odd coefficient on theta. And it's going to be double if it's an even. Now, you can imagine that if I had made this a 4, you'd be having to graph 8 petals, which would kind of take a little bit longer. So that's why I didn't put that on here. But if you want to look, okay, let me change this to a 4. Then you're going to see that all of a sudden now you have 8 petals on your flower. So if it's an even theta, you're doubling. If it's an odd theta, you're going to keep it the same. All right, turn the page. Go ahead and type in number 11. We want 4 sine theta plus 2. 4 sine theta plus 2. Okay, then go ahead and hit graph. Okay, we're going to call this a lily pad. Okay, now you'll notice the reason it's not just a regular flower is that if you add a number to your theta, to your sine or cosine theta, it kind of totally changes the shape. So we have a big loop that is how tall? 6, and how tall is the little loop? 2. So where that's coming from is that your 2 right here is going to form the little loop, and then you're going to add these together to see how tall the big lily pad is. So it's 6. So 1, 2, 3, 4, 5, 6. Okay. But again, you don't have to graph these without the calculator. In on-ramps, they actually do. But you guys. All right, next one. Go ahead and type it in. 4 sine 2 theta plus 1. 4 sine 2 theta. And then plus 1. Okay, you'll notice that this time, okay, we have 4 petals, but they're all different lengths. Your short petals, okay, are going to be length 4. And then your big petals are going to be 4 plus 1, which is 5. So your short petals should be 4. 1, 2, 3, 4. And then your big petals should be 5. 1, 2, 3. Okay. All right, then we have one more left down there at the bottom. 4 plus 4 cosine theta. Okay, you'll notice that this one is almost kind of a lily pad, but it's missing that center loop. Okay, so usually we'd call this a heart pattern. Okay, but the names really aren't important. You'll be picking it for your homework. Okay. What is 4 plus 4 here when I add those coefficients? What's 4 plus 4? 8, and that's how long the lily pad stretches on the x-axis. So you would count out to the 8th ring. 1, 2, 3, 4, 5, 6, 7. We'll say 8 is here. And then you're just gonna kind of make a heart shape. All right. Last one, go ahead and type it in. We want cosine 3x plus 2. Okay, cosine 3x plus 2. Okay. This one is a shape that kind of looks like a wiener, but we're gonna ignore that. 1, 2, 3. And then 1, 2, 3. 2, 3. And you don't draw this one. 1, 2. Sorry about. We could have picked a better shape than that. All right, there you go. There it is. Okay, you get the idea? All right, now there's one shape that we have not covered. So if you'll turn back one page, you'll notice that the only option that you have to graph is R equals, right? So if they give you an R equals, you can type it into the calculator. But if you turn back and look at the one that we skipped, instead of it being an R equals, it's a theta equals. Essentially what that means is that you want every point along that direction. So if pi thirds is here, then I want 1 pi thirds, 2 pi thirds, 3 pi thirds, 4 pi thirds, 5 pi thirds, 6 pi thirds. Then I'm going to have a straight line essentially going through pi thirds. Now, if I want every possible radius, that also includes any negative radius lengths, which means not only am I going to draw my line towards pi thirds, but I'm also going to stretch it through all of the negative pi thirds. So if you get a theta equals, and then no extra stuff, just like a specific angle, you're going to draw a straight line through that angle. Okay? All right, so that being said, pull out your Chromebook. I'm going to do maybe 1 or 2 of these graphs with you just to make sure you understand how to do it, and then you'll have the rest of class to work. All right, you should be able to see it now. Okay, and then when you're ready, go ahead and just go into the very first question. Okay, when I say first question, I mean the first of the graphing. All right, so the first couple of graphing ones, you all have the exact same question. So it's theta equals pi thirds. Can I type that into my calculator if my only option is r equals? No, then it's a straight line. So pick the straight line option. And then you're going to align it onto pi thirds. Now, if you forget, I wish that they had labeled it on here, but they didn't. Okay, if you forget which line is which, just look on your sheet and you can see where the pi thirds line is. Okay, but it's going to be this one right here. You should be 2 lines away from straight up. Okay, then go ahead and hit submit. So if it's a theta equals, you want a perfectly straight line, okay, and you need it to correspond with what the theta is that they picked. Am I good to go off of that one? All right, go into the next one. So now we're on the second graphing polars. Oh wait, that's the same. Let's skip that one. All right, go down to the third one. I have r equals 4. Can I put that in my calculator? Yes. So in your calculator, type in r equals 4. Just a 4, nothing else. And then hit graph. Okay, is it a flower, a circle, a little one of these guys, a lily pad, or a heart, or this guy? This one looks like a circle, but it's actually flat at the bottom. And then this is your straight line. So which one do I want? Perfect circle. Now remember, on your calculator, it looks like an oval, but that's because your screen's not a perfect square. Okay, then where is my circle centered? Is it centered in the middle? Yes, and what ring should it stretch out to? So 1, 2, 3, 4. Okay. Now, if I needed to be off center, I would use that blue dot in the middle and like rotate it up or down. Okay, so you want to pick the first circle option, stretch it out to the 4th ring, but keep it centered around the origin. Then you can submit. Are we all good with that? All right, let's go 2 more below that. We'll just do 1 more. Okay, go ahead and type that guy into your calculator. Oh, you don't. Yeah, that's the one. Okay, so look for 3 cosine 2 theta. 3 cosine 2 theta. What's the shape? It's a flower, so pick the flower. Then it's going to ask you how many petals you want. So looking at your flower, how many petals does it have? 4. Okay, then you're going to stretch the petals to be the length that you want them to be. How long are the petals? 3. And how else do you know that? Because of the 3 in the front, right? So you can take that little dot for your petal, stretch it out to be 3. Make sense? Okay. Do y'all think you could do this now by yourself? Okay. All right. Ask me if you need help. If you need resets from last time's homework, go ahead and just let me know about that. And then you can do it. Off last time's or this? Got it.